So here we have a function given by x squared plus 1 minus cosine of x divided by x sine of x. Now when we substitute for the value of x into a given trigonometric function, so what we obtain is an indeterminate form of 0 over 0. So that means we need to simplify a given function. So we know that 1 minus cosine of x is given by 2 sine squared x over 2. So let us substitute this value into our numerator. So that will give us limit x approaching 0. So we have x squared. Now 1 minus cosine of x will be replaced by 2 times sine squared x over 2 divided by x sine x. Now what we're going to do, we're going to divide the numerator and the denominator by x squared. So that will give us 1 plus 2 times sine squared x over 2 divided by x squared whole divided by, so x sine x over x squared was going to give us sine x over x. Now what we will do is we are going to divide this x squared by 4 and we are going to multiply by 1/4, so that we get limit x approaching 0 1 plus, so 2 times 1/4 will give us half. So we can rewrite sine squared x over 2 as the product of sine x over 2 divided by x over 2 times sine x over 2 divided by x over 2. This is the whole numerator is divided by sine x over x. Now we're going to apply the limiting value to each of the terms. So the limiting value of 1 will be 1, it being a constant. We have a half, which is a constant, multiplied to the limiting value of sine x over 2 divided by x over 2. Now this as per definition, so we have limit x tending to 0 sine x over x is going to be equals to 1. So this definition can also be applied to sine x over 2 divided by x over 2. So its limiting value is 1. So we have 1 multiplied to 1. So that's simply half divided by 1. So that gives us a final value of 3 over 2. So this is the limiting value of the given function when x approaches 0. So let us do another problem. So we need to find a limiting value of the given trigonometric function when x approaches 0. So let us begin by simplifying our given function. That's because if we do a direct substitution for the value of x, it's going to give us the indeterminate form of 0 over 0. So let us simplify it. So we have tangent of x, so that can be written as the ratio of sine over cosine of x minus the sine of x divided by, now we have sine 3x. Now sine 3x is an identity which can be expanded to give us 3 sine of x minus 4 sine cubed x. So we have in the denominator 3 sine x minus 4 sine cubed x minus 3 sine x, which will be, so we can, that will help us cancel out 3 sine x and negative 3 sine x. And then we have limit x approaching 0. So we combine the two terms in the numerator. So we have sine x minus sine x times cosine of x divided by the denominator, the sine of x, multiplied to minus 4 sine cubed x. Now we can combine the sine x in the numerator. We are going to take sine x as the common factor, so that leaves us with 1 minus cosine of x divided by negative 4 times cosine of x times sine cubed x. So we can factor out 1 sine x from the numerator and 1 from the denominator. So we have sine squared x in the denominator. So we have now negative 1 over 4 limit extending to 0. So we have 1 minus cosine of x, so that can be also equals to sine squared x over 2 divided by cosine of x times sine squared x. So we can bring the 2 to the front, so we have negative 2 over 4 times limit extending to 0. We have sine squared x over 2. So let's break it down and write it as sine x over 2 times sine x over 2 divided by cosine of x times sine squared x. Now we are going to divide the numerator and the denominator by x squared. So that will give us, so negative 2 over 4 is going to give us negative half. So we have limit x tending to 0. Now since we are dividing it by x squared, so we can rewrite it as sine x over 2 times divided by x times sine x over 2 divided by x whole divided by cosine of x times sine squared x. So we'll rewrite it as sine x over x times sine x over x. So now we need an x over 2 in the denominator. So that means we have to multiply by half. We need an x over 2 here to take care of that extra half too. We have to multiply by half. Now we take this half, multiply to this half to the front of the limit. So that will give us negative 1 over half times half times half is going to give us negative half over 8. And finally, we apply the limiting value to each of the function. So as per definition, we have sine x over 2 divided by x over 2. So the limiting value is going to be 1 multiplied to 1 divided by sine of 0 times the limiting value, which is 1. So that gives us negative 1 over 8 because cosine of 0 is 1. So let us do another problem. So here we have the function x tangent of 4x divided by 1 minus cosine of 4x. So the denominator, which is 1 minus cosine of 4x. So here we are going to apply the identity where we have 1 minus cosine of 2x is given by 2 sine squared x. So that means if we have 1 minus cosine of 4x, that will becomes 2 times sine squared 2x. So let us replace this value into a denominator. So we have limit x approaching 0. So we have x multiplied to tangent of 4x divided by 2 times sine squared 2x. Now we're going to divide the numerator and the denominator by 4x squared. So we have x tangent of 4x divided by 4x squared whole divided by 2 sine squared 2x divided by 4x squared, which will give us limit x tending to 0. So x over 4x squared is going to give us tangent of 4x divided by 4x whole divided by sine 2 times sine twice of x divided by 2 times x times sine of 2x divided by 2 of x. Limit x tending to 0. So we can take out the half to the front. So we have tangent of 4x whole divided by 4x divided by sine 2x divided by 2x times sine 2x divided by 2x, which will be equals to half. Now when we apply the limiting value of x going to 0 to each of the function, so the numerator, which is tangent of 4x over 4x, will be 1 as per our definition. Sine 2x over 2x is also going to give us 1. So the final limiting value is going to be equals to half. Let us do another problem. So here we have the function 1 minus cosine of 2x plus tangent squared x divided by x sine x. So what we can do here is we can substitute 1 minus cosine of 2x with 2 sine squared x, because that's an identity, plus tangent squared x divided by x sine x. Now we're going to divide both the numerator and the denominator by x squared. So that gives us 2 times sine squared x over x squared plus tangent squared x over x squared whole divided by x sine x over x squared is simply going to be sine x over x. Now when we apply the limiting value, that is going to give us 2 times 1 plus 1 over 1, which is equals to 3. So let us do another problem. So we need to determine the limiting value of the given function. So let us begin by separating the numerator. So we have x squared over tangent of x minus tangent of 2x over tangent of x. Now the limiting value of the first trigonometric function will be, we can rewrite it as x times x over tangent of x minus tangent of 2x can be written as the ratio of sine 2x over cosine 2x, and we have a tangent of x in the numerator, so that can also be written as the ratio of sine x over cosine of x. Now when we apply the limiting value to each of the functions, so we have limiting x, limit x going to 0 of x times limit x going to 0 x over tangent of x minus, now sine 2x is an identity which when expanded gives us 2 times sine x times cosine of x. So let us substitute. So we have 2 times sine of x times cosine of x. So we have one more cosine of x, so that will get multiplied to give us cosine squared x. We have cosine of 2x times sine of x. So here there's one more thing that we need to do here. So we have to apply the limiting value to here as well. So we have limit x tending to 0. So there is a sine x in both the numerator and the denominator, so that gets cancelled out. So the limiting value of x when x tends to 0 is going to be equals to 0. And as per our definition, so we have the limiting value of x over 10x is equals to 1 minus 2 times the limit x tending to 0. So we have cosine squared x over cosine of 2x. So 0 times 1 is going to give us 0. So we have negative 2 times cosine squared 0 over cosine of 2 times 0, which is also 0. Now cosine of 0 is 1, so that gives us a limiting value of negative 2. So we need to determine the limiting value of the given function. So what we're going to do, we will use the identity that cosine of a minus the cosine of b is equals to negative 2 times sine a plus b over 2 times sine a minus b over 2. Let me rewrite it. A minus b over 2. So let's apply this identity to our numerator. So we have limit x approaching 0. We have sine 2x. So we have negative 2. So let's write it in the front. So we have negative 2 times sine. So 3x plus 4x is going to give us 4x over 2 times sine a minus b. So 3x minus x is going to give us 2x over 2 divided by x cubed. So we have negative 2 times limit x approaching 0 sine 2x times sine 4x over 2 is going to give us 2x times sine 2x over 2 is going to give us simply x. Now we have x cubed, so we can rewrite x cubed as x times x times x, so that will help us to determine the limiting value. Now for the function sine 2x, we need to have a 2 in the denominator, so we multiply x by 2, and that means we have to multiply 2 to the entire function. Similarly, here we have to multiply x by 2, and then we multiply 2 the entire function. So we have negative 2 times 2 times 2, so that is going to give us negative 8, and the limiting value of each of the functions are going to be 1. So this gives us the limiting value of the given function as negative 8.